In this AP Calculus question, we're being given the derivative f prime of x of our function f, and then it wants to know which of the following values does f have a local minimum. So this is really a first derivative test, and if we think about it, just talking through what a local min or a local max would look like on a first derivative test, normally you would come in and you would mark your critical value wherever that was, wherever the derivative was equal to 0. And then if you wanted a minimum, you would expect the graph to be headed down. It would be decreasing. And then headed up, it would be positive and increasing. So this would give us a local min. That's what it looks like on the number line, but what would it look like if we put it on a graph? So if we graphed our derivative, remember that what we're looking for is a place where the graph changes from negative to positive. When you're looking now at the graph of the derivative, wherever the graph is up above the x-axis, that's where it's positive. That's where it would be increasing. Wherever the graph is down below in the negative space, that's where the graph would have been decreasing. And then whenever we hit this axis here, that's when it would be 0, and that would be where we have a critical value. And so if we were looking at a graph of this and taking this data through, what we would want is we would want the graph to somehow start down here in the negative, have a critical value, so hit this 0, and then be back up here in the positive space. And so that's what a local min would look like if we were graphing it on an x and y axis. Well, since this is a calculator required section, we're going to do it that way because that's going to make our lives a heck of a lot easier, and we don't have to go through any type of algebra to get to our critical values. We don't have to do any test values. We just get to use the calculator. So what we'll do is in y1 on our calculator, we're going to put our derivative function. Then in y2, we're going to put 0 because that's where it's going to hit the axis. Those are going to be the critical values, and those are the places where we're going to have local maxes and mins. Once we do that, step 2 of the process, we're just going to hit the graph button. And then from there, we will go ahead and we'll read off the graph, looking for something that gives us a negative into positive movement because we're looking for a local min. And then we'll hit second, calc, and inside the calc menu we'll choose the number 5 option, which is intersect. The place where our derivative and our 0 intersect each other and give us the shape we're looking for is going to be where we have a local minimum. So we'll open up our calculator, go to our y equals, we'll type in our derivative equation, which they gave us for free, and we want to know when does that equal 0. Remember when you're graphing on the AP Calc test, you always want to graph everything in radians. And then from there, step 1, enter it in. Step 2, graph it. And so now I'm looking at this window that's got stuff happening all over the place. So while it's not saying it only has one local min, remember. This question is saying at which of the following values of x does it have a local min? And so what we'd want to do here is kind of squeeze our window in, right? We'd have 0 is the smallest number, and then 3.545 is the largest. So maybe I would want to set my x min so that I can make sure that I see 0. So maybe I'll put that at -1. And then I'll set my x max to be something bigger than 3.5. I would set my x max to 4. So we'll go into our window now, and we'll squeeze this thing down because we don't need all the local mins and maxes. We just want the local min that's on our list of options. So I'll put my x min at -1. I'll put my x max at 4. And you saw how wide this thing was. You don't have to do this, but I would definitely recommend kind of moving my window down to just being between -1 and 1. Because all we're looking for here is we just want to know when does it run into 0. And so I don't need to have my y mins and maxes so big. So then I'll graph this, and now I'm looking through here, and now I can start coming through and saying, okay, where am I going from negative to positive in this graph? Going from negative to positive is where I would expect to see a minimum. So I can see that I'm going from negative to positive once right here, and I'm also going from negative to positive a second time over here. So we're going to go calculate those two intersects because those would be where the mins are happening, and we'll see if one of those matches any of the x values we were given. So second calc, we're on step 3 now, hit that number 5 option, intersect. From there, it's going to ask us a series of 3 questions every time. The first 2 we could really care less about. It's going to say, is this the first curve? Yep, that's the first curve. Go ahead and hit enter. It's going to move automatically to the second curve for you and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. And then the last question is the important one. We want to guess. So all we're doing is just pushing this cursor over here so it's close to where we want to look for our intersect. We hit enter a third and final time. It will say the word intersection, and then that x value down below there is our answer. So we know that at x equals 2.506, probably round that to 3 decimals when you're on the AP Calc test, so x equals 2.507. That would be an option for where we have a local min. And then we'll go calc the other one. So second calc, number 5 intersect. First curve hit enter, second curve hit enter, and then the other place it's going from negative to positive is right there. So I want to guess there. So then I hit a third and final time on guess. It says the word intersection, and again, AP Calc questions like to round to 3 decimals, so this would be x equals 3.545. Now we go and look. These are both local mins, but only one of them is available for an answer, and that's this one. This one matches up with option C, so option C would be our answer on this question. Thanks for watching my video. If you liked it, please click that like button and subscribe, and also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.